Well, this is the last video for Math 111, and this is going to be a sample final exam. So I'll just go over the problems on the sample final, and alright, let's see here. So we'll go in the order that the course went. We'll start at the very beginning and work our way through to those last couple topics that we were going over this week. So problem 1 starts out 2 times x minus 3 squared minus x plus 1 times x plus 7. Okay, a lot of this is about the order of operations. We want to square this x minus 3 first before we distribute the 2 inside. Okay. Also, we want to multiply these together, but then also distribute this negative sign or -1, depending on how you want to think of it. The other important idea here is that when you square something, that means that you multiply it by itself. Okay? And so you get x squared minus 6x plus 9. So we'll still have the 2 here, x squared minus 6x plus 9. And then I'll keep the parentheses here for the x squared plus 8x plus 7, because now I have to distribute the negative into this parentheses and the 2 into this parentheses. So 2x squared minus 12x plus 18, and then minus x squared minus 8x and minus 7. So we come out with 1x squared minus 20x and plus 11. Okay. Alright, problem 2 is about adding and subtracting fractions. In this case, it looks like we're subtracting x over x plus 1 minus 2 over x plus 3. And so the idea here is that we want to make a common denominator, which is x plus 1 times x plus 3. So this one gets multiplied by x plus 1 over x plus 1. And this one gets multiplied by x plus 3 over x plus 3. So here we'll have x times x plus 3 minus 2 times x plus 1. So what do we come out with here? X squared plus 3x minus 2x minus 2 over x plus 1 times x plus 3. So x squared plus x minus 2 over x plus 1 times x plus 3. And I think that's going to be lowest terms. You can factor the top here. I think it's x plus 2 times x minus 1, right? But that's not going to cancel anything. And so these are both correct. They're both the same thing. Either one is fine. Okay. All right. Well, let's take a look at problem 3. So problem 3, you've got these two fractions equal to each other. X minus 4 over x equals 1 over 2x plus 1. And so we'll solve this by cross multiplying. And this will say x minus 4 times 2x plus 1 equals 1 times x. Okay? So this will be, let's see, 2x squared minus 8x plus 1x. So that's minus 7x. Minus 4 equals x. Move this to the other side. 2x squared minus 8x minus 4 equals 0. So this is quadratic. So we'll run it through the quadratic formula. And let's see. 2a is 2. B is minus 8. C is minus 4. And so we get x approximately equal to 4.449 or negative 0.449. Okay. Problem 4 is a little bit more difficult. In In this one, we have to clear out denominators or build common denominators, depending on how you want to think about it. 1 over x minus 5 plus 1 over x minus 1 equals 5 over x squared minus 6x plus 5. Okay? So, right, these two denominators are prime. This one factors as the product of the other two, right? X minus 5 times x minus 1. So this is our common denominator. We'll turn these two into this one by multiplying here by x minus 1 over x minus 1, and here by x minus 5 over x minus 5. So, over on this side, we'll have x minus 5 times x minus 1 as the denominator. Here, 1 times x minus 1 plus 1 times x minus 5. And then on the other side, the 5 over x minus 5 times x minus 1. And the process here, we can just pick these numerators off and set them equal to each other. I talked about why that is. Or we can go ahead and take the explicit step of actually multiplying on both sides and clearing out the denominator. Up here, that leaves us with 2x minus 6 equals 5. This is easier than a quadratic equation, right? Don't forget how to solve the easy ones. This is a linear equation. Get the x by itself. Add 6 to both sides. 2x equals 11. X is 5.5. Okay? A lot of times people get to this point and we do so much with quadratic equations, they just look at this and just throw up their hands. Oh, I don't know how to do this. It's the easy one. This is the easy one. This is from Math 70. It's from Algebra 1. So please don't forget how to do that. All right. Oh, that is page 1 of the sample final. Let's look over on page 2. Okay. Problem 5. Let's see. We've got x cubed minus 7x squared plus 5x plus 12 less than 0. Okay? Well, let's look at the graph here. Okay, so x cubed, 7x squared, plus 5x plus 12. And again, I always encourage you to double check what you've typed in if you're going to be relying on the calculator to solve the problem. And I'll show you what this looks like in the standard window. Let's see what we've got here. Okay, so that's the standard window. You can see we've got 3 roots there. So I'll go in and use the root finder on the calculator to determine those roots. And let's see what they are here. Let me draw a little sketch of our graph. Something along those lines. And so that first root there is 0.954. And let's see here, the next one. 2.179. And then this last one is 5.774. Okay, and the problem is asking us where is y less than 0, right? Because this is what we graphed as y. So the question now is where is y less than 0? Okay, well that's going to be in here, right? Y less than 0, and also over here, y less than 0. So that's x less than 0. That's negative 0.954. There we go. Or x less than 5.774, but greater than 2.179. Okay? Well, that's problem 5. Okay, let's take a look at number 6. So this one, we've got a rational inequality. So we've got x squared minus 6x minus 2 on top, and x squared plus 3x minus 6 on the bottom. So before I graph it, I'm going to go through this process where I find out what are the roots and what are the asymptotes, right? The roots are where the numerator is equal to 0. Let's see where that's going to be. Okay, 1, -6, and -2. So we should look for roots at 6.317 or -0.317. And then the asymptotes, that's going to be where x squared plus 3x minus 6 equals 0. So A is 1, B is 3, C is -6. And we should see those asymptotes at 1.372 or -4.372. Okay, so there we go. Let's go ahead now and graph this thing and see what it looks like. X squared minus 6x minus 2 over x squared plus 3x minus 6. And again, let's double check that we got everything typed in correctly. And then I'll show you what it looks like on the calculator here. Okay, and let's see. I can see that one asymptote there. Yeah, that looks like 1.372. And then we've got an asymptote over here on the negative side, -4.372. So let me sketch a little graph on the board for this one. So let's see here. 1.372, -4.372. So this one is out here. This one is kind of doing that. And then this one here does that. Okay? Now notice it's a little bit hard to see, and I talked about this when we were covering this topic. It's a little bit hard to see in here whether or not this is actually a root, but we know from doing the quadratic formula that it is. There's a root there at 6.317, and there's another one here at -0.317. And then these asymptotes are 1.372 and -4.372. Okay, so we've identified all these critical values, and so now we want to answer the question, where is this thing greater than 0? Where are the y's greater than 0? So that's going to be up here, here, and there. Okay, so where is that? That is x greater than 6.317. Or, here, let me mark it off on here. There's that region, and then this one, and then that one. Okay? So this will be, let's see, x less than 1.372 and greater than -0.317, or one more, x less than -4.372. So, there we go. Problems 5 and 6. This is a polynomial inequality. This one's a rational inequality. And we solve them by graphing. Alrighty? Okay. Let's see here. Then we've got the last part of Chapter 2. This was the first part of Chapter 2, these two questions. And then the last part of chapter 2 are all about those roots and using synthetic division. So let's take a look at those. Okay. Oh, problem 7. Let's see here. 8x cubed, 2x squared, 17x plus 15. And so what we're going to do is graph this, see what it looks like. Okay, so 8x cubed, 2x squared, plus 17x plus 15. All right. Let's see here. What does our graph look like? Really all we see is that. Okay, so let's go in here and find out where that root is. Negative 0.75. Okay, so I'm going to call this negative 3/4. I prefer to work in fractions because it makes it easier to build a factor out of our answer. Okay, because we know that if our answer is x equals negative 3/4, then 4x is negative 3, 4x plus 3 equals 0, and one of our factors is going to be 4x plus 3. Okay, to find out what the other factor is, then we want to do synthetic division. So let's take the 8, 2, 17, 15, and divide with this minus 3/4. So that'll be 8. Let's see, negative 6, negative 4, positive 3, 20, and then negative 15, and that makes 0. And again, if it's easier for you to do it on the calculator, by all means do that. It's just time consuming for me to keep going back and forth between the calculator and the board. So remember, notice that we've got a common factor here that's always the same as that denominator. So we want to factor that out. Right, and that'll leave us with 2 minus 1 and 5. So this is 2x squared minus 1x plus 5. And let's see, so let's run that through the quadratic. 2x squared minus x plus 5 equals 0. And let's see what we get here. And so our complex valued answers are positive 0.25 plus or minus 1.561 I. So 2 complex answers, 1 real answer, and that makes 3 answers for an x cubed problem. Okay, let's look at problem 8. 3x to the 4th minus 4x cubed minus 7x squared minus 20x minus 12 equals 0. Okay, well let's go ahead and graph that one and see what it looks like. Let's see, 3x to the 4th, 4x cubed, 7x squared minus 20x minus 12. And again, as always, I encourage you to double check what you've typed in. And let's see what we're going to see here. So it looks like we've got 2 real roots on this. Let's go in and find out what they are. That one is negative 2/3. And the other one And this one was probably, I could have seen that in the table because it's a whole number, right? If you go look in the table, yeah, when x is 3, y is 0. Okay, so Now we've got two real roots here. X is negative 2/3. That means 3x is negative 2. And 3x plus 2 equals 0. So there's one factor, 3x plus 2. If x equals 3, x minus 3 equals 0. So that means we've got a factor of x minus 3. And the question is, what's this missing factor? Right here. So let's use our synthetic division. 3 minus 4 minus 7 minus 20 minus 12. So minus 2/3 minus 2 minus 6 positive 4 minus 3 positive 2 negative 18 positive 12, right? And if this is a root, you should always get a 0 remainder there. And let's see, what else? 3. 9, 3, 9, 6, 18. And again, notice you've got a common factor that matches that denominator, so we want to factor that out. And so this will be 1, 1, and 2. X squared plus x plus 2. And then we'll run this through the quadratic and find the complex roots. Okay, 1, 1, and 2. And so this says x is negative 1/2 plus or minus 1.323i. So 2 complex roots, 2 real roots, that makes 4 roots. And so we found them all. Alright, so that's it for chapter 2. Let's move on to the next page of the final. Now we've got problems 9, 10, 11, and 12, which come from chapter 3, about how to solve exponential and logarithmic equations. And you do have the properties of logarithms at the top of this page, so you don't have to memorize them, and you don't really need to put them on your note card either. You can save that space for something else that's not going to be on the test paper itself. Okay. So, problem 9, we start out pretty simple. 8 to the x power equals 20. So, before I do anything, it should be clear, if you think about this, x should be somewhere between 1 and 2, right? Because 8 to the first power is 8. 8 to the second power is 64. Since 20 is between 8 and 64, x should be between 1 and 2. Okay? That's the way our number system works. So, that's something to think about. Now, to solve this, the process that we went through was to take a logarithm on both sides. Whether you use log base 10 or log base e, doesn't make any difference at all so long as you're consistent, okay? So I'll start out by using a log base 10. Take the log on both sides, so this will be x log 8 equals log 20. And these are numbers, and so I can divide on both sides by log 8. And so there's our answer in exact terms. But I do ask that you approximate this to 3 decimal places. So let's take a look at what we get when we do that. So log of 20, close parentheses, divided by log of 8. And that comes out to be about 1.441. Okay? So if we round this to 3 decimal places, we get 1.441. To check this, I'm going to round it to an extra decimal place and try out 8 to the 1.4406. And we get almost 20, 19.998. Okay, so there's all the calculator work that I was doing for that problem, log of 20 divided by log of 8. And then I checked it by doing 8 to the 1.4406 power. And that gave me just about 20. So that gives me some confidence that I've got the correct answer. All right, problem 10 is a little bit more complicated. Well, let's see what we've got here. 5 to the 2x plus 1 equals 7 to the x plus 1. All right, so we're going to follow the same method as we did in problem 9. I used log base 10 in this one. I'll use the natural log, log base e, in problem 10. So then the 2x plus 1 comes down in front times ln 5 and the x plus 1 times ln 7. So I'll solve this in two different ways because I know that there are two different ways to solve this, and some of you might prefer one method, some of you might prefer the other method. Okay? So the first thing I'm going to do is I'm going to distribute these logarithms without approximating them. So I'm going to get, so if I distribute here, I'll get x times 2 ln 5 plus ln 5 equals x ln 7 plus 1 times ln 7. Okay? So, I'll move the ln 5 over here, and I'll move that x ln 7 over there. So, here we get x times 2 ln 5 minus x times ln 7 equals ln 7 minus ln 5. So the trick here is to factor out that x, and then what we're left with there, this is what we'll divide by on both sides. 2 ln 5 minus ln 7. So that cancels out, and here's our answer. ln 7 minus ln 5 over 2 ln 5 minus ln 7. And now we can make a good approximation for this. Let's see what we get. All right, so ln 7 minus ln 5. And then we want to divide by 2 ln 5 minus ln 7. And that comes out to be about 0.264. And let's see. We can check it in our answer here. Let's see here. 5 to the 2 times 0.264 plus 1. And what is that? 11.695. And then 7 to the 1.264. 11.700. So not bad. We're pretty close, right? If we want better accuracy here, then we'll need more accuracy in our answer. Okay, so now the other method for solving this is to stop right here and make a good approximation for ln 5. 1.60944. And then over here, ln 7, 1.9459. 9459. Okay. So, again, and then it's the same process here. We're going to distribute. So, let's see here. 1.60944 times 2. 3.2188x. And then 1.60944. Over here, 1.9459x and 1.9459. And then we do the same thing we did over here. We're going to subtract this 1.60944 on both sides. So those cancel out. And then we're going to subtract 1.9459x. On both sides. So those cancel out. Okay, so over here, 19459 minus 1.60944 gives us 0.3367 3.646. And then over here, 3.2188 minus 1.9459x gives us 1.2729x. Okay. Let's see here. Oh, this is 888. Okay, so I'm going to have a little bit of an, if I hadn't caught that, I would have had a little bit of an error in my answer. So let's see, 27298. Okay. So now we need to divide. 0.33646 divided by 1.27298. Let's see what we get. It should be 0.264. Yeah, 0.264. Okay, so there's those two problems, 9 and 10. Those are the exponential problems, and we use logarithms to bring these variables down out of the exponent so that we can work with them like a regular algebraic equation. And again, there's two different ways to do it. Whichever one makes the most sense to you is the way that you should choose. Okay? If you're going to make the approximations, please make good approximations. You know, don't just call this 1.6. All right? Because I'm asking you to round to 3 decimal places, and so you should approximate these logarithms to at least 4 or 5 places to make sure that you don't lose that accuracy. All right, now let's look at the logarithm problems. Problem 11. Let's see here. Log to the base 5 of x minus 2 plus log to the base 5 of x equals 2. Okay. So the idea here is that we want to use the properties of logarithms to put these two together. This will be log to the base 5 of x times x minus 2 equal to 2. And then we can restate this, right, using the definition of a logarithm. 5 to the second power equals x times x minus 2. So 25 is x squared minus 2x. And here's a nice quadratic equation. And let's get some solutions here. So a is 1, b is negative 2, c is negative 25. So x could be 6.099 or negative 4.099. Okay, that's problem 11. Problem 12, let's see, we start off ln of 2x minus ln of x plus 1 equals ln of x minus 4. Okay, so now let's see here. Yeah, we're going to restate this as the natural log of 2x over x plus 1, right? Because that's subtraction. So now we've got this on one side, this on the other side. You've got a log equal to a log with the same base. That says that these two things themselves have to be equal to each other. Okay, so 2x over x plus 1 equals x minus 4. To clear out this denominator, we're going to multiply on both sides by x plus 1. So these cancel and leave us with 2x over here. X squared minus 3x minus 4. So let's, oops, there we go. And this will give us x squared minus 5x minus 4. And let's see what solutions we get from that. So a is 1, b is negative 5, c is negative 4. And so x is 5.702 negative 0.702. Okay, so last problem is on the last page of the sample final here, and this one we can solve graphically. Now it's a little bit tricky because you have to pick the window, pick a good window to look at the graph in, but you get that typed in and then I'll show you a good way to go about doing that. So let's see. So sodium-24 is a radioactive isotope that's used to study circulatory dysfunction. 4 micrograms of sodium-24 are injected into a patient, and then the amount of sodium-24 still present in the patient's bloodstream after T hours is given by A of T is 4e to the minus 0.0462t. Okay, so let's look at the graph here. Now this one, because of this 4 in front, right, this is going to show up in the standard window, okay? Now if you remember some of those other problems that we were doing, right, when this number was outside of the window, outside of the standard window, it became a little bit trickier to find where the graph was, okay? So I'll show you what this graph looks like. And this is still the standard window from negative 10 to positive 10 on both the x's and the y's. And you can see that graph is right there. But let's say that instead of 4 micrograms, let's say they were given 40. Okay? So let's see. So now I'm changing the problems just to illustrate something about the graph. Okay? So I've changed the problem now so that there's 40. And now if we go to look at the graph, you can see there's nothing there. So if that happens, what you want to do is go look in the table. Let's see here if I can get that table to come up. There we go. Go look in the table and see what these values are for these, all right, when x is 0, y is 40, and then it's coming down from there. So that says go into the window, right, and make your y maximum equal to 40. And now if we go back to the graph, there, we've got a much better look, okay? We still want to expand those x's out, but at least you can see where the graph is. Okay, so that was just an example to remind us of how to find that graph, okay, when it doesn't appear in the standard window. So let's go back to the problem that we're actually doing, which is 4e to the minus 0.462t. The t is in hours, okay? That's important to know which units we're working in. What amount of sodium-24 will be present after 5 hours? Well, one thing you can do here is just go right back to that table. And let's see, when t is equal to 5, what is that? 3.175. Okay, so part A, at t equals 5, A is about 3.175. You can get that from the table. You can also calculate this directly. 4 to the times e to the minus 0.0462 times 5. So if I go out to the calculation window, there's what we get, right? There's the direct calculation, 3.1749. So you can see a higher level of accuracy, but it's still approximately 3.175. micrograms. Okay. Let's see here, part B. How long will it take for there to be 1.7 micrograms of sodium-24 left? So this is the place, you can do this algebraically if you'd like to, right? This is 4 right here. And we want to graph this on the same axes with y equals 1.7, right? So this is A equal to 1.7, and we're looking for a value of t. So we're going to graph a line here at y equals 1.7. Okay. So there it is, and then we go and look at the graph. There's 1.7, and they don't intersect yet. So now I've got to go into the window here, and I've got to open up my x's a little bit, make my x maximum 20. Let's see, there's the original graph. There's the y equals 1.7, and there's an intersection. So then we go second, trace, right, go down to intersect, choice number 5, or you can just type in a 5. Yeah, curve 1, curve 2, guess, and there's our answer. Let's see, what is that? 18.521. Okay, so here our answer is t is approximately 18.521. And you can solve this algebraically if you really want to, but that's kind of a long, involved process. So I'm not going to do that on the board. There's nothing wrong with it. If you choose to solve the problem that way, you'll still get it right. Okay? I'm just not going to take the time to go over it on the board. Okay, so that's it. That's the whole final exam. Don't forget you can bring a note card, 3x5 note card with notes on the front and back. I mentioned already that you'll have those rules of logarithms will be on the test paper itself. So take a look and so that you know what's going to be there for you, and then what you want to write on your note card for reference when you're taking the test. And as always, if you have any questions, please let me know.